Hello and welcome to another video. In this video we're going to be finishing up the Uber interview series by doing the Uber mock onsite. I think this has one of the lowest ones out of all these. I guess about the same as some other ones, about 34% looks like. There are some that are like 32 or something, but close enough. Okay, so yeah, and the goal is going to be to have clean code, do hards in 25 minutes and mediums in 15 or so. So see how this goes. And it's going to be 3 to 4 questions in 2 hours. So try to get it done in an hour or less. Alright, given the head of a linked list, find the value of the next greater node. For each node, find the value to the first node that's next to it. Turn it into an answer. Alright. I don't think we have to connect it. Yeah, we return a list. Alright. So I think the plan here is just use a stack. Yeah, so I think we just have a stack of node. Anytime we reach a node that's bigger, we will return. Yeah, we will put in that value, I guess. Yeah. Okay. Okay. And yeah, so we're not given a list. We're given a linked list. Yeah. Yeah. So essentially, we're just gonna put all the nodes into a list and then do all that. Okay. So, and if it doesn't exist, we'll do answer, so we'll do res. I guess we don't know how many nodes there are, so first I guess maybe let's put all the nodes in a list and then do it. So we'll have 2 steps. We'll first put all the nodes in a list just so we know how long it is. Yeah. Yeah, that'll be easier. So I think you could do this with a 1 pass as well if you want to. But I think we'll just go with a 2 pass. Yeah. Yeah, okay, fine. Okay, so let's just have nodes. And then say while head. Nodes append head. Or yeah. I guess we'll just get all the values. Yeah, sure, we'll do the values. And then we'll do node head equals head next. Yeah. Could do this in 1 pass, but for the sake of like just getting something done, we'll do it this way. Nodes n. Yeah, so we're gonna have a value, at least 1. Okay, cool. Now that we have nodes, now we just need a stack. And now this is just like a next greater element for each of these. So we'll have a result. I can even have this. And 0. Shows everything 0, and then we just go through all the nodes. So nodes, while stack, and the value is strictly greater than stack -1. We'll have the value at index 1. So we'll write this really quickly. So our format of our stack will be index value. Okay, so while the value is strictly greater, result at stack -1 0 equals v. All right, and then we will then we just push on the stack. Okay, and return result. All right, let's go with that. Okay. Right, moving on. You're given array of positive integers w, where w is the weight. You need to implement the function pick index, which randomly picks an index and returns it. The probability of picking an index is just, interesting, is the weight over sum. Oh, okay, I see. So it's not even. So it's like, I guess you have like weighted. You have some like weighted indices, and then the ones that are weighted higher will get picked higher. Yeah, so here, okay, sure. All right. So pick index picks an index and returns it. Okay. So pick index returns 1. I see. Okay. Randomization, multiple answers are correct. Okay. So it should mostly pick, okay, yeah. And it initializes the array, right? Okay, so picking index, you can't specify a range. You have to do it. You have to do the total. Okay, sure. And how many times can this get called? Okay, so we need to pick index to work in like linear or like log time. So essentially, like let's say we have a sum here. Like let's say we have all these values like 1, 2, 3, whatever, and the sum of this guy is what 15, 18. So essentially, we want to pick a random value, like basically random value 1 through sum. I'll look up the. I don't remember how to do that in Python. We can look that up. Then when we pick that random value, we want to know like where does that go? And how do we do that really quickly? Essentially, so like let's say we pick value like 11. We could figure out where it goes in log time. I don't know if we can figure out an 01 time, but log was still going to be fine. Yeah, so maybe that's going to be the solution we're going to go for, is a log time. Well, actually, no, we could do an 01. Yeah, we could definitely do an 01. Okay, I think I got it. So, yeah, okay. So I think the way to do this is, what's the biggest value you can have? So the biggest value is 10 to the 5th. So if we have 10 to the 5th, it's the biggest value we can have, and we have 10 of them. We might time out actually doing a linear solution, because the sum can be, yeah, it's problematic. Yeah, because here, if this is it, then our total can be really big. Like, the sum can be 10 to the 9th. I was going to say, one solution we can have is just literally, like, if it's 1, we'll just say 1 maps to index 0. And then 2, or yeah, then like 2 maps to index 1. And then like 3 maps to index 1, and so on. That would be, this pick index would be 01. This would be longer. But this would be, if we do it that way, this would be this times this, which wouldn't be good. So I think we're going to go with the other solution of instead have pick index be log and have this be linear time. Yeah, I mean, maybe there's something better, but we'll double check there later. So the way to do that is going to be, we just do a prefix sum. So this will be like 1, 3, 7, 12, 18 or something. Yeah. And basically we pick a random number between 1 through the total, or just some randint or whatever it is. Look that up. So let's say we get a number 5. So then we basically look for the index that is, I guess, we want to figure out if it's greater than or equal to, or like it's going to be like the smallest index that's greater, like the biggest index that's smaller, one of those. So obviously if we pick a number that's exact, then we're done, right? Like if we pick like 7, then we just get it. But what if we pick a number like 5? Yeah, I think it's going to be smallest index that's greater. So, and this is just binary search. So like we can start with this as like the default, and then we're essentially, if we get an index that's greater, we'll mark that as a result and we'll go left. And let's try this with a couple numbers. Let's say we get a 4. 4 would be in this range, which would be correct. Let's say we get like 13. 13 would be here. Yeah, I think this is good. All right, so we'll go with that solution. Okay, yeah. Yeah, so this is just given an array, right? Yeah, okay. So we need to actually store that as well. Okay, yeah, let's just... All right. So now pick index. So let's look up random number Python or something. Python 1 to n. There's like randint or whatever it is. Generate. Okay, random rand int inclusive. Okay, that's what we want. So okay. Yeah, so num rand int 1 to total. Right. Now we will say that left to right equals 0 length of self sums. Result equals, we'll go with the right index. Okay. And then the rest is just binary search. If self sums p is greater than or equal to, I mean, we could check for the equal and return right away, I guess. So if it's equal to num, return p. If self sums p is greater than num, we'll mark it that one. And then we are going to go left. So, and otherwise, yeah, I also don't know how they're going to grade this one. If it's probability, if you can literally just return anything and it'll be true, but this should be correct. Sorry. Let's see. Total. All right. Okay. Yeah, I don't know how they grade it, but I guess we can run it a few times just to see that it does give you different stuff. Yeah, so here it gives you 0. And if we run it like a few more times, I guess. Actually, no, this one only has, never mind. Yeah, this one only has, we want to try this one. Just to convince ourselves that this is working correctly. So essentially we want 1 to get picked more often, but we want 0 to get picked sometimes. And it should be just like different things. Yeah, it looks like that's the case. All right, cool. So I'm pretty sure this is fine. All right, let's move on. Okay, last one. Given 2 strings, this one is 2. Find if S3 is formed by interleaving. Yeah, definitely easier. I mean, I've definitely done this problem sometime, but definitely easier than the Google one. The Google one, the last question was pretty hard. I think this one, well, let's see. Interleaving strings. Okay, so yeah, so definitely have done something like this. So essentially, if we're given 2 strings, we can basically find if we can find the third one in some way with a substring. All right, yeah, sure. And basically, it's pretty straightforward, I want to say. So this is just basic DP. Essentially, we're going to have some character we're looking for in S3, and we're going to have some index we're on in S1 and S2. And then if that character is equal to S3, then we can try that character. So for example, here, like we're going to be on this character, and we're going to be on this character and this character, and then we can only use S1, so we'll try S1. And if you're on some character in S3 and neither S1 or S2 match, you just return false right away. If they both match, you try both. So just simple. We'll just go top-down DP, easier. So we'll go S1 or I1, I2, I3. And you can actually record 3, or you could calculate 3. But this is actually going to be I1 times I2, because I3 is dependent on these two, so you can either calculate or include. I'm just going to go with including. It's going to be same space and all that, so hopefully that makes sense. Because basically, for whenever these two are some value, this is always going to be the same value compared to those two. Yeah, okay. So we can say if I3 equals length of S3, then we have a success. We don't need to check for the cache because you can use a cache decorator. Then we just check like if S1 is equal to the character, we'll try that. If S2 is, we'll try that. So if S1 or I1 is less than length of S1 and S3 at I3 equals S1 I1. Then we'll try to do this. So if dp of, so we'll move up. So if we're using the character from the first string, we'll move up I1. We'll keep I2 the same. We'll move up this one. Turn true. Same exact thing for the second one. So if I2 is listened to S3 I3 to I2, dp I2, I1 this stays the same. This one goes up now. Okay, and if you can't do this, just return false. And just return dp at 0, 0, 0. Okay. Right. Ooh. Oh, one more case that I forgot. So so my case was assuming that S1, the length of the first string and the length of the second string add up to the length of the third string. That has to be the case if you're interleaving. So if length of S1, I thought that was the case in the constraints, but I guess not. Okay, plus S2 does not equal length of S3, then this is impossible. So we just do a false ahead of time. All right, let's go with that. Okay, nice. Yeah, so this was definitely, it's funny, this is the most failed, but I feel like I just got super easy questions. I did have to redo one of these for a video because I got some multi-threading thing, which like I just don't know multi-threading well. So, and also I feel like that shouldn't be a really good question. So, but yeah, definitely got kind of like the easier one here. So I'll probably do some other ones in the future, but I think probably now I'm going to move on to like doing more system design and some other stuff, system design front end, but definitely going to revisit this in the future, and then just kind of do different things. And yeah, let me know in the comments, I guess, like what kind of videos you want me to say. I think people are asking like, what are you studying for? I'm not really studying for anything in particular. I'm literally just making videos and random things that I think will be interesting. So, and I do think, yeah, like from having done these on-sites, like for other stuff, usually they're pretty difficult. So definitely got one on the much easier side of it. But yeah, let me know what you think. And yeah, I'll see you in the next one. Thanks for watching.